Number 16 here is a problem that, quite frankly, some of you guys are going to whip right through with no trouble at all, and others of us are going to struggle with a little bit. And it kind of comes down to your ability to have like spatial reasoning right here. And also, I hate to say this, kind of your artistic abilities can kind of come into play when we're doing something like this. So they've given us 6 quick small graphs right here. They just want us to sketch the graph of the inverse for each one of these. So let's take a look, and I'll just go one at a time, starting at A. You'll notice this graph passes through the origin, 0, 0. So when you invert that, you'll still end up with 0, 0. But whereas this graph kind of increases into the first quadrant, but then levels off, where x gets really big, but y doesn't, now the inverse will do the opposite. Y is going to get really big where x isn't. So I think this graph is going to look maybe a little something like that. And then just kind of reversing what it did in the third quadrant, kind of the same basic idea like that. So I don't know that I drew this perfectly, guys, but that's a decent sketch for what the inverse of graph A might look like. Now B is a funny one because B exists entirely in the first quadrant, where both your x coordinate and your y coordinate are positive. And when you invert a first quadrant point, it was positive comma positive. When you invert that, oh, you still end up with positive positive. So since this graph was entirely in the first quadrant, its inverse is going to be entirely in the first quadrant as well. But as I'm looking at that, it definitely looks like their graph here is a little bit smooshed, that's a technical term, over to the left, and it looks like it's a little closer to the y-axis than it is to the x. That means that its inverse is going to do the opposite of that. So the inverse right here, I think, is going to do something that looks maybe a little more like that. I don't think I drew that very well. Let me try a slightly different method right here. If I drew that dotted line of y equals x going right here like that, anywhere that the original function crosses the line y equals x, the inverse will pass through the exact same point. Okay, and now as I'm just trying to be artistic about this, I feel like this is going to be a slightly sharper turn right here and a little more gradual up here on this side. And now as I look at the red and the blue curves, there's some decent symmetry there over that line y equals x. Not great, but not bad. Okay, how about C? Pretty clearly, we're looking at what appears to be, I should say, an upward opening parabola here with its vertex at the origin. So again, at the origin, 0, 0, that point inverts to itself. So our inverse is still going to pass through the origin. But here's how I would look at this one. The original function opens upward, guys, along the positive y-axis. So therefore, its inverse is going to open up along the positive x-axis, and the inverse of this function is just going to be a sideways parabola that opens off to the right. How about D? Now this kind of looks like we have a downward opening parabola, but we're not at the origin anymore like we were before. It kind of seems like in D we have a point right over here that's our vertex that, again, I'm just totally guessing here, but it looks like it's higher than it is to the right. So maybe something like 5, 10. That means that its inverse now would be at the point 10, 5, which might look like this somewhere. The red curve, it looks like it had an axis of symmetry right about there. So the blue curve would have a horizontal axis of symmetry going through its vertex like that. And it kind of looks like the red curve began at the origin. The blue curve will pass through that same point. So I think with this, guys, I could draw this part and this part of the curve and call that pretty good. Now again, I want you to see this here. If I were to go back and draw the line y equals x, I obviously didn't do that perfect. This point of intersection right here should have been right there. A function should always cross its inverse on the line y equals x. Looks like I did pretty well right here, but I kind of missed a point there. Okay, close enough. How about point E? Looks like we have a function that's increasing at a slow rate here. So maybe an exponential function with a relatively low coefficient or a number out in front of the base of your exponent. So again, I'd probably just do this one with my line y equals x right here and just try to draw a blue curve now that mirrors the shape of that red one. So I would think about this point here, reflecting it over the line y equals x, and that would get me to right about here. I'd maybe do the same with my y-intercept. Okay, that'll become an x-intercept. And maybe like one more point over here. If I come straight there, that's going to get me about here. And I think this blue curve now is going to connect those 3 points and maybe look something like that. So that's kind of a geometric way of doing it here in part E. Now, F is another graph that's kind of interesting, like B, because both F and B seem to exist pretty much entirely in the first quadrant. And again, when you invert a first quadrant point, you still get a first quadrant point. What I do think I noticed, though, about this linear function in F is that your y-intercept right here appears to be a smaller number than your x-intercept right over here. Like, for example, if this y-intercept was like 5, it maybe looks to me like your y-intercept there would be about 7. That means then that when we invert that, those numbers will change. This distance from here to here is 7, and that now transfers up here somewhere. I don't know what that was I just drew. So just kind of eyeballing from here to here, I'm now going to go up here and say, okay, that is roughly 7 units up on my y-axis. My x-intercept only needs to go to about 5. So I'll go ahead now and connect those 2 points, and I think what we have in blue there is a pretty good guess for our inverse. And one more time, if I drew the line y equals x, passing through the origin with a slope of 1, that looks pretty good to me. Those 2 lines really should be intersecting at that point right there, so I don't think I did it perfectly, but I think you get the point. We're just going for impressionism here, and that's what number 16 would look like.